Very good morning, children. Welcome to the another session of 10th class physical science, reflection of light at curved surfaces. Our today's topic is sign convention parameters and also the mirror formula. See, children, in this video class, we are going to learn about sign convention parameters. How to give the sign, whether we used to give plus or minus, what is the sign convention to be used while doing the calculations. So before learning about sign convention parameters, we will see the mirror formula. This mirror formula is the one which gives the relation between u and v. See, children, what is u and v? Here the terms u represents the object distance and v represents the image distance. The relation between object distance and image distance which are present in front of the concave mirror are given by this formula, that is 1 by f is equal to 1 by v plus 1 by u. This 1 by f is equal to 1 by v plus 1 by u is called a mirror formula. Okay, in this formula, small f represents focal length, u represents object distance and v represents image distance. Okay. While using this formula for calculations, to calculate the object distance as well as the image distance, in every situation, we have to use the sign convention. So, how to use the sign convention? There are some rules to give the sign for any calculations. Okay, sign convention rules. In that first one is, it says all distances should be measured from the pole. So, all distances should be measured from the pole. See here, I have drawn this concave mirror. I represented the midpoint of the mirror, that is called pole, with letter P, and I have represented F here. F is nothing but focal point of the concave mirror, and C represents the center of curvature of the concave mirror. Okay, I have represented object and image also. Here I have taken the object. Where is the position of the object in this diagram? So you can observe that object is in between the mirror and focal point. That means in between the pole and focal point of that mirror. When the object is placed in this position in between P and F, this is the only case in front of the concave mirror. This is the only case where we get the image of this particular object is beyond the mirror. Okay, behind the mirror we will get the image. So here I means it is the image and O is the object. So children, this is very important thing. In all other cases, when the object is placed upon this principal axis anywhere except this place, either it may be on F or in between C and F or on F, on C or beyond C. And in all these cases, the image is going to be formed in front of the concave mirror only. This side only we will get the image. But only in this case, when the object is placed in between P and F, we will get its image behind the concave mirror. Okay. Now, whatever it may be, wherever may be the object or image, if we want to measure the distance of object or if we want to measure the distance of the image, we need to always measure from the pole. Suppose if you want to measure the object distance, that is u. Okay, we need to measure the distance of object from the pole in this direction. From the pole in this direction. Here to here in this direction. P to O we have to measure. Okay, from the pole. And if we want to measure the distance of image, then also we should not go in this direction, but we should measure it from the pole. That means in this direction, here to here, like this. In this direction only. All the distances should be measured from the pole. This is the meaning of the first one. Anyhow, focus will be lying in front of the concave mirror and we will be measuring here to here. This distance represents the focal length, small f. Okay, it is also we have to measure from the pole only. Don't go in the reverse direction. Always measure the all distances from the pole only. Okay, children. See, children, there are two more rules for sign convention. Okay, second one, you see, the distances measuring in the direction of incident light are to be taken positive, and the distances measuring in the direction opposite to the incident light to be taken negative. That means, children, see this diagram. Here, this is the concave mirror and this is the reflecting surface. This is the back side of the mirror, which is painted one. Okay, this side, front side, which is acting as a reflecting surface. The light rays will be reflected from this side. Okay, from where the object is there, from the object, the incident light rays will be coming and focusing on this concave mirror. Okay, this is the reflecting surface of the concave mirror. Now let us assume that the object is placed in between pole and focus. Okay, in between pole and focus. Now, in which direction the light rays are coming and striking the concave surface? So this is the object. So from the object, the light rays will be coming and striking the concave mirror. So in this direction, what is this direction? This is the direction of the incident light rays. The light, for suppose if an object is placed here or here, suppose if an object is placed here also, again from this side only the light rays will be coming. So this is the incident light ray direction, the direction of the incident light ray. Okay, I is nothing but incident ray. Okay, this is the incident rays are coming in this direction. Incident rays are coming in this direction. This is the light incident ray direction. Now, according to the first rule, the object distance should be measured from the pole. So object is here, pole is here. From the pole, we have to start measuring the distance of the object. That means here to here, like this we have to measure from the pole. So see this direction, children, in which direction we are measuring the distance of the object. In this direction we are measuring, and this is the incident light ray direction. So incident light rays will be coming and falling like in this direction. So we are measuring the object distance towards the right. Okay, this incident light ray direction is towards the left, and the direction of the measuring of the object distance is towards the right. This direction, in which direction we are measuring the object distance, is opposite in the direction of the light ray incident. So if it is in the direction, see here, the distance is measuring in the direction opposite to the incident light to be taken as negative. In this case, the object distance should be taken as negative quantity. Object distance, suppose here to here, if it is 2 centimeters is there, let us assume if 2 centimeters is there object distance. So object distance is represented with u is equal to minus 2 centimeters we have to take. Why? Because why I am taking minus here? Because we are measuring the distance of the object in the opposite direction of the incident light ray direction. Hence we have to take minus. And the magnitude is 2 centimeters here to here distance. Therefore 2 centimeters. U is equal to minus 2 centimeters. Now go for the image distance. Image distance, how to measure? In the rule 1 we have already studied that any distance that should be measured from the pole only. So here is the pole, here is the image. From the pole to image we have to measure. That means this is the pole. Okay, this is the pole and this is the image. In this direction we have to measure. Okay, this is the image. Okay, this is the image, and from pole to towards the image we are measuring in this direction. This is our measuring the direction of measuring. Okay, and this is the incident light ray direction, and this is from right to left, and this image distance is also from right to left in the same direction. So the direction which is measuring in the direction of the incident light ray, in the same direction of the incident light ray, then that distances should be taken as a positive quantity according to the rule. See here, the distance is measuring in the direction of incident light to be taken positive. So in the same direction, if we are measuring the direction which is measuring the distance which is measuring in the same direction of the incident light ray, in that case, so what is this we have measured here? Image distance. So image distance is represented with v. V is equal to, this distance may be some 3 centimeters, like that you assume that it is 3 centimeters. Then okay, it is in the same direction. Now hence we have to take it as a positive quantity. Therefore v is equal to 3 centimeters, like this we have to take. Previous one, u is equal to minus 2 we have taken. Why we got minus here? Because the object measuring distance is in the opposite direction to that of the incident light ray direction. But here image distance measuring is in the same direction of the incident light ray. Hence we have taken here a positive quantity, and here we have taken as negative quantity. That is about the sign conventional rule 2. And the next one is, while measuring the heights of the object, heights of the image, height of the object is represented with HO and height of the image is represented with HI. Okay, these objects are also having certain height. Okay, and height of the object and height of the image are positive if they are measured upwards from the axis. Okay, and negative if they are measured downwards from the axis. That means children, see here, now we can take another example. That suppose if we are having the object here, let us assume that the object is placed here. Here the object is placed. Don't look at these two. Now red color one object you see. When the object is placed between C and F, you all know that where do we get the image of this object? This image of this object we will get beyond the C. This is the center of curvature beyond C, and like this we will get. Okay, so here this is the image formed here. Now, so object, height of the object means here to here, the height of the object, that is HO. HO should be measured. How can we measure? This is the principal axis. from the principal axis, we have to move in the upward direction or in the downward direction. See, object height should be measured from the upward direction from the principal axis, and image height should be measured from the principal axis in the downward direction, as we are getting the image in the downward direction. That means inverted image we are getting, no? Hence the height of the image should be measured from the principal axis in the downward direction. Okay, here to here is the height of the image, that is hi. See, this is ho should be measured from the principal axis to the in the upward direction. Hence in the upward direction we are measuring, hence it should be taken as positive quantity. Suppose here to here some 2 is there, 2 centimeters is there, then we have to take it as +2. And image height of the image, how can we measure? From the principal axis in the downward direction we have to measure the height of the image. Here to here some 3 centimeters, like it is there, magnitude. Then we have to take it as hi, height of the image, is equal to, we are moving in the downward direction, no, from the principal axis, hence we have to take it as the negative quantity. Therefore hi is equal to -3. Like this we have to take. Okay, positive and negative. Here also sign convention should be given like this. Whenever we are measuring the height of the object from the principal axis in the upward direction, that quantity should be taken as the positive. Whenever we are measuring the height of the image from the principal axis in the downward direction, we have to take that magnitude in the negative quantity. Okay, like this. So height of the object and height of the image should be taken or positive if measured upwards from the axis. Here axis means principal axis, and negative if they are measured downwards from the axis. So these are the sign convention rules, children. So if we keep all these rules in our mind while doing the calculations, we can use plus and minus signs can be easily kept by us. Thank you for watching. We will meet with another topic in the next session.